This is SpaceTime, Series 23, Episode 118. Coming up on SpaceTime. When we look at the stars, is there anyone looking back? Another delay for Russia's space station science module. And NASA warns the US Congress about China's new space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Three decades after Cornell astronomer Carl Sagan first suggested that Voyager 1 snap a picture of the Earth from billions of kilometres away, resulting in the now iconic pale blue dot photograph, two astronomers now offer another unique cosmic perspective. They point out that some exoplanets, that is, planets orbiting stars other than our Sun, have a direct line of sight to be able to observe Earth's biological qualities from far, far away. Cornell University's Lisa Kaltenegger and Joshua Pepper from Lehigh University have identified 1,004 main sequence stars similar to our Sun that might contain Earth-like planets in their habitable zones, all within 300 light-years of Earth, and which should be able to detect the Earth's chemical traces for life. Their study, reported in the monthly notices of the Royal Astronomical Society, reverses the viewpoint to that from other stars, and asks from which vantage point other observers could find Earth as a transiting planet. A transiting planet is one which, from the observer's line of sight, passes in front of its host star, thereby revealing clues about it and the makeup of its atmosphere. Kaltenegger says that if observers were out there searching, just as Earth's astronomers are, they'd be able to see a biosphere in the atmosphere of our pale blue dot. And she points out that some of the brightest of these stars are actually visible in our night sky without the need of binoculars or telescopes. Kaltenegger says astronomers will soon start using the James Webb Space Telescope. It's due to be launched next year on an Ariane 5 rocket. And James Webb will allow scientists to undertake transit observations looking for inhabited extrasolar planets. But exactly which star systems are likely to be looking back at Earth? Well, holding the key to this science is Earth's ecliptic, that is the plane of Earth's orbit around the Sun. The ecliptic is where exoplanets with a view of Earth transiting would be located, as they'll be the places able to see Earth crossing in front of or transiting the Sun from their viewpoint, effectively providing any alien observers looking a way to discover our planet's vibrant biosphere. Pepper and Kaltenegger have created a list of 1,004 closest stars using NASA's TESS Transiting Exoplanet Survey satellite, listing those systems in our stellar neighbourhood which would see Earth transiting the Sun, calling their attention. Kaltenegger says if Earth astronomers found a planet with a vibrant biosphere, they'd certainly get curious about whether or not someone's looking back, and this new TESS star map suggests the sort of places they should be looking first.
In our search for life in the universe, we ask a little bit of a different question in this research. We ask, who could have actually spotted us? Who could have found out that Earth is teeming with life from their vantage point? Because it takes a specific location to be able to see the Earth go in front of its star, the Sun, and then once a year, if you see the Earth go in front of the Sun from your point of view, the Sun would be just a little bit less bright. And so you would know a planet orbits it. And you would also know it's at the right distance so it could have liquid water, one of the key ingredients for life. And so we identified the 1,000 closest stars within 300 light years roughly that could have spotted us already. Maybe there's life out there in the universe. Maybe they already spotted us. What would they think?
That's Lisa Kaltenegger from Cornell University. And this is SpaceTime. Still to come, another delay for the long-awaited Russian space station science module. And NASA warns the US Congress about China's new space station. All that and more coming up on SpaceTime. The The Russian Federal Space Agency Roscosmos says it now plans to launch its Nauka science module to the International Space Station in April next year. Originally built in 1995 as a ground copy of the Zarya module, it was converted to a flight-capable module in 2004 as a cost-saving measure by Roscosmos. Nauka was meant to replace the Russian Pirs docking port this month. It was originally slated to launch back in 2007, but it's been repeatedly delayed by a seemingly never-ending string of technical issues, including faulty fuel valves in the propulsion system that required extensive cleaning and ultimately replacing most of the plumbing. But then the entire propulsion system needed to be replaced anyway after surpassing its use-by date. Once that was done, they discovered metallic dust contamination inside the fuel tanks, and that resulted in the need for more cleaning and refurbishment. However, those repairs turned out not to be successful, resulting in the decision to build a new replacement tank instead, and further pushing back the launch date to this year. When it does finally fly, the 13-metre-long Nauka will be Russia's primary science station research module used for experiments, docking and cargo. The 2,300-kilogram module will also serve as a crew rest area. And it won't be alone. Roscosmos have also announced plans to launch a new connecting node called the Precal Nodal module in September. The ball-shaped Precal will be docked next to Nauka and have 6 docking ports, an active port which will be attached to Nauka, and 5 passive docking ports for visiting Soyuz and Progress spacecraft. This is SpaceTime. Still to come, NASA warns the US Congress about China's new space station, and the Seven Sisters, the Andromeda Galaxy, and 3 meteor showers are the highlights of the night skies of November on Skywatch. The US Congress has been warned that it was crucial for America to maintain a significant presence in low Earth orbit once the International Space Station's finally decommissioned in order to prevent China from gaining a strategic advantage. The warning by NASA Chief Jim Bridenstine comes as the space station prepares to celebrate 20 years of continuous human occupation. The orbiting outpost's first modules were launched in 1998, and it's been continuously manned since the year 2000. At the moment, the space station's expected to continue operations until 2030. But in 2024, it'll be joined by a second, much smaller space station called Gateway, which will be located in translunar orbit and will act as a staging post for missions down to the lunar surface, and ultimately, missions to Mars. Bridenstine warned lawmakers that it was crucial for the United States to maintain space supremacy in low Earth orbit in the face of China's new space station, which will begin assembly in orbit in 2022. He says he's concerned that the day is coming when the International Space Station comes to the end of its useful life and Washington needs to prepare for what comes next. Bridenstine's called for an allocation of $150 million for the 2021 fiscal year to help develop the commercialization of low Earth orbit, defined as 2,000 kilometres or less from the planet's surface. Now, he's not interested in NASA building another international space station, but rather supporting the development of a fully commercial orbiting outpost through a public-private partnership where NASA can deal with commercial space station providers. Beijing's official state-run Xinhua news agency says the new Tiangong, or Heavenly Palace Chinese International Space Station, has already signed up 23 entities from 17 countries to carry out scientific experiments aboard their new orbiting outpost, including France, Germany, Japan, Kenya and Peru. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian and Etruscan mythical winged horse, who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. It's estimated to have about 185 times the Sun's radius and 12 times its mass. Epsilon Pegasi, together with the stars Markab, Al-Janib, Shahid and Alpha Andromedae, forms the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked eye stars shaped like a square. One of the stars in this constellation is 51 Pegasi, the first star system beyond the Sun to be discovered to have an orbiting planet, a so-called exoplanet. In this case, a hot Jupiter, a gas giant so close it orbits its host star in a matter of days. By the way, a light year? Well, that's the distance a photon can travel in a year at the speed of light, which is some 300,000 kilometres per second in a vacuum, and the ultimate speed limit of the universe. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located around 33,600 light-years away. Globular clusters are tight balls containing thousands of stars, which are all originally formed at the same time out of the same molecular gas and dust cloud. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains around 100,000 stars, making it one of the most densely packed globular clusters in the entire Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars orbiting very rapidly around what appears to be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars including one double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're in or near the Northern Hemisphere and away from city lights, you'll notice a fuzzy patch of light right next to Pegasus. This is the giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in our local galactic group. Located some 2.5 million light-years away, Andromeda consists of more than 1 trillion stars, around twice the number found in the Milky Way. And it's huge, some 220,000 light-years across. Based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also has far less new star production going on than our galaxy. And the rate of supernovae in the Milky Way is also about double that in Andromeda. Andromeda is surrounded by a large, massive halo of hot gas and plasma, estimated to contain at least half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That's almost halfway towards the Milky Way. Using a good pair of binoculars or a backyard telescope, you'll see dark dust lanes in Andromeda's spiral arms, and you'll see its bright central galactic core. Now, over time, Andromeda will become a lot clearer. That's because it's getting closer. You see, the Milky Way and Andromeda are expected to collide in about 3.7 to 4.5 billion years from now, the two spirals eventually merging to form a new giant elliptical galaxy. What that means for the future of the Earth, the Sun and our solar system is a matter of great ongoing debate. The gravitational tidal perturbations from the encounter could rip our solar system apart, or even fling us out into intergalactic space. At this stage, only time will tell. Now, looking to the east and slightly south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. The brightest star in the constellation is Beta Ceti or Deneb Katos, an orange giant located 96 light-years away. The name Deneb Katos means the whale's tail. Another one of the stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 days, changing in diameter from around 400 to 500 times the diameter of our Sun. Also visible is Alpha Ceti, traditionally called Menkar the Nose. It's a red-hued giant star some 220 light-years away. It's actually a double star, with a secondary 93 Ceti being a blue-white star some 440 light-years away. Also in Cetus, located some 11.9 light-years away, is the yellow dwarf star Tau Ceti, the nearest Sun-like star to the Earth other than the Sun. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and other characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. That's followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, Then comes spectral type G yellow stars. That's where our sun fits in. Slightly cooler are spectral type K orange stars. And then the coolest and least massive stars known are spectral type M red stars. Each spectral classification can then further be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So at the end of all that, our Sun is classified as a G2V, or if you prefer G25, yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but then became brown dwarfs after losing some of their mass. Brown dwarfs fit in a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Looking south from Cetus now, and you'll see the brilliant star Acamar, which means the river's end, and marks the end of the celestial river Eridanus. Follow Eridanus towards the east, and you'll see the magnificent constellation Orion the Hunter, a familiar signpost for southern summer skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova on July the 4th in the year 1054. They recorded the sudden appearance of a new star on their sky charts at the exact position of the Crab Nebula. The supernova appeared brighter than the planet Venus for weeks on end, before finally fading completely from view after almost 2 years. The Crab Nebula is located some 7,000 light-years away. It's expanding at a rate of over 5 million kilometres per hour. At the heart of the nebula is a rapidly spinning neutron star or pulsar, rotating some 30 times every second. It's emitting radiation in all wavelengths, from gamma rays and X-rays through ultraviolet, optical and infrared, and on into radio waves. Observations indicate the pulsar's spin rate is slowing down, and it will fall to just half its current rotational rate in the next 1,000 years. November is also a great time to check out the Pleiades or Seven Sisters, one of the nearest and most spectacular open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus. Now, depending on whose measurements you prefer, the Pleiades are located somewhere between 118 and 137 parsecs away, a parsec being 3.26 light-years. The Pleiades are composed of mostly hot blue-white stars. Amazingly, different cultures in vastly different parts of the world all describe the Pleiades as seven sisters or seven women, possibly some sort of ancient throwback to very early human civilization. Just like October, November also sees 3 meteor showers. There's the November Orionids, as well as the Taurids and the Leonids. Although peaking in late October, the Orionids continue to sprinkle down during the start of November, and are usually at their best in the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter, hence their name. The Taurids are generated by the comet Encke, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Now, Encke and the Taurids are believed to be the remnants of a much larger comet which disintegrated sometime in the past 20,000 to 30,000 years, breaking into several pieces and releasing material by normal cometary activity and maybe occasionally through close encounters with the gravitational tidal force of the Earth and other planets. In fact, the cometary stream of material from the Taurids is the largest in the inner solar system, and being so spread out, the Earth takes several weeks to pass through it all. That means there's an extended period of meteor activity compared to the much smaller periods of activity for other meteor showers. Interactions with the giant gas planet Jupiter have also caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to around November the 25th, while the northern Taurids go from October the 12th to around December the 2nd. The Taurids are usually quite diffuse, only producing about 7 meteors per hour. However, they're composed of far more massive material. Think of pebbles instead of dust grains, and so they tend to produce a higher percentage of very bright meteors known as fireballs, produced by the larger meteoroids burning through the atmosphere. The southern Taurids should be putting on their best show just after midnight around now. The third meteor shower in November are the Leonids, which peak around November the 18th. They usually produce around 15 meteors an hour, but have been known to occasionally produce some spectacular meteor storms, with showers in 1999, 2001 and 2002 producing around 3,000 Leonid meteors per hour. But one of the best had to have been the Leonids meteor shower of 1966, which generated, literally thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. Produced by debris from the comet Tempel-Tuttle, the Leonids radiate out from the constellation Leo the Lion. And they're a fast-moving stream, encountering the path of the Earth at 72 kilometres per second. Larger Leonids, which are about 10 millimetres across, can have a mass of half a gram and are known to generate really bright meteors. It's been calculated that the annual Leonids meteor shower can deposit 12 to 13 tonnes of particles across the planet. Joining us now is Jonathan Alley, the editor of Australian Sky and Telescope magazine, to continue our tour of the November night skies.
G'day, Stuart. Well, November, so we're heading towards summer. For us, in Australia at least, November is considered the last month of spring. So we're almost there into summer, so the weather's nicer, the nights are warmer, the hours of nighttime are shorter though, because it's coming onto summer. It's good observing weather, that's the main thing. So let's start with what we can see in the mid-evening sort of sky. So we've got the Milky Way, which is our galaxy seen from the inside, and that's hugging the western horizon at the moment, over where the sun has gone down. So after the sun's gone down, it's dark. The Milky Way is hugging the western horizon, and we can just see the tail and the stinger of the constellation Scorpius, the scorpion, just sticking up over the horizon. And you've got Sagittarius nearby. When we look towards Sagittarius, we're looking towards the centre of our galaxy, the centre of the Milky Way. In the northern half of the sky, going around to the right, in the northern half of the sky, looks pretty bare. It's filled with a couple of big constellations that have very few bright stars. You've got Pegasus, the winged horse. You've got Pisces, the fish. You've got one called Cetus, or Cetus, the whale. You've got Aries, the ram. You've got one called Eridanus, the river, which is just a very long, thin constellation that winds all the way from the northern hemisphere down the southern hemisphere. You'd never pick it out in the night sky if you went out there to look at it. Someone's just joined up a lot of dots in the sky and called that a river. But over in the eastern part of the sky, we've got Orion coming up over the horizon in the sort of mid-evening. That's a sign for us here in the south that summer's approaching. For our friends in the northern half of the planet, that means winter's approaching for them. Down in the south, you've got the Southern Cross. Well, you probably can't see the Southern Cross actually, because at this time of year, it's down at its lowest. It's right down either on the horizon for many people, or even below the horizon, depending on which city you live in if you're a bit further north. So don't expect to see it in the evening hours this time of year. But if you happen to be up and about, 3 o'clock in the morning or something crazy like that, you will see it. As the Earth has rotated, the Southern Cross will have swung up into the sky a bit, and it'll be down there in the south. If you do spot the cross, also have a look for the 2 pointer stars. We've mentioned these before. You've got Alpha Centauri and Beta Centauri. They're really 2 bright stars very near the Southern Cross, and they're close together, and they point towards the Southern Cross. And Alpha Centauri, of course, was the destination for the Jupiter 2 in the TV series Lost in Space.
Oh, the pain. The pain.
So by early morning, about 3 a.m., if you are up at that time of night for some reason or other, or if you're getting up early, 5 o'clock or 6 o'clock or whatever, then you'll see that the sky has changed quite a lot as the Earth has rotated and brought new constellations into view. So Orion now will be really up nice and high in the northern sky. We've got the constellation Canis Major with its bright star Sirius. We've got Gemini, you've got Leo, you've got Cancer, all up there in the northern half of the sky as seen from the southern hemisphere. Really nice time of year. And as the weather gets on towards summer, and it's lovely in the evening. It's just beautiful constellations and stars up and about to see. It was the time of year when I first started getting into amateur astronomy when I was a teenager and learning my way around the sky. Couldn't have been better, because it's just the most fabulous constellations to see and really easy things to spot, really easy star patterns to spot if you're just learning, okay? So really, if you get some clear skies during November, get out and have a look. Grab hold of Australian Sky and Telescope. We've got our star chart in the middle of it, which will help you identify the constellations and stars and things, just to get yourself going. And then you never know, you might turn it into a lifelong hobby, because it is a really good hobby. So that's what's happening in the constellations and stars and everything. Let's look at the planets. In the evening sky, we have Jupiter and Saturn, one above the other in the west after sunset. Now, these two are really dominating the sky at the moment. They're big and bright. They're about halfway up from the horizon as the sky it gets dark, as the sun has gone down. Jupiter is the bigger, brighter one on the bottom, and you've got Saturn above it, a little bit dimmer, but they'll look tremendous together, these two planets. They're the two gas giant planets in our solar system. And they're going to stay there in the western sky all through the month, but slowly getting lower and lower toward the horizon as each day goes past. Have a look on the 19th of November and you'll see the moon very, very close to Jupiter. So if you're having trouble spotting which one's Jupiter, have a look on the 19th and look at the bright thing that's very close to the moon, and that'll be Jupiter. And not only are they getting sort of slightly lower and lower as the month goes on, but they'll also be getting closer and closer together. And they'll end the month quite close, and going into December then, they're going to be really, really close together. In fact, in December, there's going to be the closest approach between these two planets, I think, in centuries. It's going to be really spectacular to see. For people who have a telescope, they'll be able to see the two planets together in the same field of a telescope, which is something you just never get to see. They'll be that close together. Now, when I say close together and close approach, that kind of thing, I don't mean that they are actually physically close together out there in space, hundreds of millions of kilometres away. I just mean that they appear to be close in terms of angular separation in the sky. It's a line of sight effect because Jupiter is closer than Saturn. Saturn's much further away. So they just seem to come together in the sky, but in space, really, they're a very long way apart. Now, Mars, which last month, October, was the star of the show because it reached its point of closest approach to the Earth. It's still nice and big and bright in the northern half of the sky. Again, about halfway up from the horizon in the north. It passed its closest approach on October the 6th, I think it was. Mm-hmm. So as the weeks are going by, it's slowly becoming a little bit dimmer and a little bit smaller as the distance between Earth and Mars is opening up again. So now's a good time.
To be going backwards too.
Yeah, that's what happens because we're sort of on the inside track. It's on an outside track, so we're overtaking on the inside. So yeah, when you look back towards Mars, it seems to change direction. But it's not really. It's just a line of sight effect. So yeah, have a look at it now because after a couple of months, it'll have become really small again and dimmer as this distance opens up between the two of us. Planet Mercury, is too close to the sun really to be seen this month, so I wouldn't even bother for that one. But Venus, it can be seen above the eastern horizon before dawn. You can't miss Venus. It's big and bright and marvellous and beautiful. And as the month progresses, it'll be dropping a little bit lower in the sky. So have a look now before it gets lost in the solar glare towards the end of the year. And that, Stuart, is this month's Night Sky.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.